Oh wait, has the recording started? It has started. I
Yes.
prove perfect. Okay. Wait, in fact, let me just get a problem and maybe we'll do the formulas as we go. Probably a better idea. Wait, where are the problems? Hmm. Maybe we'll start with this. Okay, first, this requires basically no formulas, so hmm. And people might have already seen this. Hmm. Okay, so wait,
Oh,
first of all,
this is the EGMO.
this is EGM. This is this year's EGMO 25 for
P4.
yep, indeed. This and a perfect example of complex function. Okay, wait. Uh, I'm assuming everyone knows what a complex number is and like how multiplication of complex numbers are rotations and stuff. Mm. So we'll do some like basic ideas and like how you want to bash. But first, let's just do some calculations to like get it out of our system. Okay. Hmm. I should define. Oh, there's n center, so I do need to cover the formulas. I forgot. Let me just get the idea. How many of you know the formula for like complex and center?
Yeah.
Okay.
I don't.
Hope I sent this in Lamau. Oh, I sent this. I don't. Okay, I'll cover this so that everyone else can like do stuff before we move on to hard problems. Okay. Wait, what's the problem again? BI and CI intersect the circumcircle at P and Q. Consider point R and S such that parallelograms. Okay, let's just see the formulas. Okay, so this is something that I think a lot of people already know, but I'll just mention this. Whenever you are complex bashing, I consider that. Yeah, whenever you are complex bashing, you want to do everything on a single circle because the formulas with respect to a circle are very nice. The more you can restrict to a single circle, the better. Like, so if you have a single circle, you say that's the complex unit circle, and then everything will be nice. Why? Well, we'll cover all the formulas, but let's start with the incenter. So, suppose there's 2 points, A, like, okay, let's just have a triangle, A. Let's just start with 2 points, A and B. Okay. So, since this is the unit circle, we generally, whenever there's like one big circle in the triangle, we'll call that the unit circle. And so, say this is the origin. So this point is like r e to the I like okay, r is 1, so this is like e to the I a, and this is like e to the I b, right? So the arc midpoint of these 2 points, that will be e to the I a plus b by 2, right? So I'm
Yeah.
not I don't have chat open, so just shout at me if you have any questions. And people who already know this can just start bashing. Yeah. E to the a plus b by 2. So that will be like, you can see that's the geometric mean of these 2 points. So square root ab. The only issue is that's not quite the case. This can also be like we also have another point here, which is also like the arc midpoint.
Wait, what
So
is
these
square
two
root
like
AB?
square root ab. So like we have e to the ia and e to the ib. You multiply them, you get e to the I a plus b, and the square root is e to the I a plus b by 2, right? I don't know.
Yeah, yeah, yeah.
And so like that means its argument is half the argument, like average of the argument of the other 2 points. Hence,
Yeah,
it's
yeah.
like the arc midpoint. But okay, the issue is there's two arc midpoints, major and minor. So the difference is like an angle of 180. So like, and also they're like opposites. So one will be square root minus AB and one will be AB. But you can't really, well, which one of them will be square root AB and which one of them will be minus square root AB, right? You can't really say that. And the second thing is complex square root already has two branches. So there's like a lot of weirdness going around here. So the way we fix this is if we ever have to like have a problem where we want to take arc midpoints and stuff in a circle. So what we do instead is we call the points a square and b square. Okay. A square, b square, and say c square. Right. And now, well, we have freedom with how to choose A, B, and C, right? For any point A, there will be two, like, for any, any point A, we can pick two different complex numbers, small a, whose square is A, right? Like, A square and minus A square are both valid choices of A. And the reason and we'll pick them in such a way, such that this minor arc midpoint is minus AB, this is minus BC, this is minus CA. Also, wait, I should give some buffer problems for those who already know. Yeah, people who already know like the basics and stuff of complex bash, try to complex bash IMO 25P2. This year's IMO 25P2. Yep.
This
That's
year's
25P2. Figure out how to complex bash it. If you already know like how to do these problems. While I cover the basics for everyone. Good luck. How do you complex? We'll get to that. Anyway. Yeah, okay. So, well, you'll notice some things. First of all, why are all of these minus? Right? Why not plus? Why don't you choose A, B, and C such that all the arc midpoints are plus? So the thing is, you can't actually do that. Um, the way you prove this is, okay. So we know all three of these points will be plus minus AB, plus minus AB, plus minus AB. We don't know which one will be plus, which one will be minus. And depending on like how we choose A, B, and C, we can get different answers. The theorem states that we can pick A, B, and C in such a way that all three of these minor arc midpoints are negative, but we cannot pick them in such a way that all three of them are positive. Yeah, I know there are two circles. Do it. I have challenged you. Yeah. Mm, okay, let me just quickly provide a proof. And so we can. Wait, triangle. Oh my. Oh, wait, why am I using trackpad to write? That's like suboptimal. Oh, no, mouse is even more suboptimal. Okay, so let's get a better diagram. Okay, so we have A, we have B, we have C, we have M, we have N right here. N is the major arc midpoint. And okay, I'll call this MA. I'll call this MB. And I'll call this MC. Right? Wait, how does this work again? Yeah. Okay. Let's see. This is V by 2. Yep, I got it. Yep. Okay. Okay, so first claim is AN MBMC is like okay, AN is parallel to MBMC. Can someone prove this? People who have not seen this before. Mm. Okay. What can you see a line that AN is perpendicular to? Please define N. MA, MB, and C are like the minor arc midpoints, and N is the major arc midpoint of BC.
It's perpendicular to AH.
AH.
Wait, no.
We want to prove AN. So AN is the external angle bisector, and AI is the internal angle bisector.
Oh, right. Yeah, just AI then.
This is 90. And why is MBMC perpendicular to AI? Yes. What what things do you know involving arc midpoints? What
MBI equal to MBA.
MB wait, what? Oh,
MBI
MBI
equal
equal.
to MBA, right?
Ah,
So it's the
yes,
perpendicular
yes,
one.
correct. So in center lemma states that AIC circle has MB as center, AIB circle has MB as center. So yeah, MCA equal MCI, MBA equal MBI. This is the perpendicular bisector. So this line is parallel to this line. And one thing you can say about parallel chords in the circle is suppose you have a chord like PQ and another chord RS. Uh, to be parallel means that, well, they have their arc midpoint is the same, right? Because like this arc length equal this arc length, and since they're parallel, this arc length equal this arc length. So like this combined arc length is equal to this combined arc length. So they have the same arc midpoint. Hence, like plus minus square root PQ will be plus minus square root RS, or PQ equal RS, right? This is the condition for two chords in a circle being parallel. So, going back here, if we have assigned A to be, say, A square, B to be B square, C to be C square, then like MA will be like, I'll call it E1 times BC, where E1 is either plus 1 or minus 1. We don't know what it is. MB will be like E2 times AC, and MC will be E3 times AB. N will be the minus of this, minus E1 times BC. So our result states like since AN is parallel to MCMB, we get E3AB times E2AC is A square times minus E1 BC. That becomes minus E1 A square BC equal E2 E3 A square BC. Wow, my handwriting's getting worse and worse. Can I?
What do you write after E2? Oh, E3. All right.
Yeah, yeah, okay. Okay. I finally figured out how to use this. Cancel the A square BC, blah blah blah. You get minus E1 square equal E1 E2 E3. And since E1 was like plus or minus 1, this is just minus 1. So the product of E1 E2 E3 is minus 1. Right. Hence, you cannot choose, like, you cannot pick A, B, and C in such a way such that all three arc midpoints are positive because their product has to be minus 1. So either you pick 1 as negative and 2 as positive, which is just weird and asymmetric. So the choice we stick with is all three are negative. Is that fine with everyone? Everyone understand the proof?
Yeah. Yes.
Yeah, good. Okay, and finally, you might know the incenter is the orthocenter of this triangle. This you can prove, well, because as we just proved, AI is perpendicular to MBMC. So like I lies on like the altitude from MB, similarly the altitude from MC and the altitude from MB, right? Hence I is the orthocenter. And well, I'll leave as like an exercise for you to try to prove. If you have a triangle ABC in the unit circle, then the orthocenter has coordinates A plus B plus C. In fact, wait, let's just quickly prove this. Um, can anyone say the proof of this? Orthocenter is A plus B plus C.
Yeah, because like the centroid is the A plus B plus C by 3, and then we take the homothety thing. Like O is just origin, right? So,
Yep, correct. So centroid is A plus B plus C by 3, O is 0, and due to Euler line, like they divide in 2:1 ratio. So you get orthocenter is A plus B plus C. So the in center is minus AB minus CA minus BC. And well, like a lot, these are basically the only like, okay, no, there's one, two,
Wait, what
a
was the
few more
proof?
formulas. What?
What was the proof for A plus B plus C?
Or circumcenter is 0 because it's the
Right.
unit circle. Centroid is
Okay.
A plus B plus C by 3. Right,
Yeah.
that's. And the idea is that the orthocenter, like this Euler line, so
Oh,
H,
okay. Yeah. Right.
Geo, right? So this is 1, this is 2. Yeah. And then you use the section formula
Okay.
and you get H. Or just homothetia. Anyway, that's that out of the way. Those are the basic formula. Let's do this problem. So, well, okay, so the points are easy to find. So like Q will be minus AB, P will be minus AC, and I will be minus AB plus minus AC minus BC. What are the R and S are the parallelograms. So how will you find R?
We will
A
use
plus
A
R
plus,
is B plus
yeah,
Q.
A plus R equal to B
Yep.
plus Q.
Midpoint is same, so you will get so R will be A plus no, R will be B plus Q minus A. So B square minus AB minus A square. And S will be, well, the same thing. A square, sorry, what am I doing? C square minus AC minus A square. Right? That's how you use symmetry. Yep. And yeah, wait, okay, whatever. That's just. Okay, T be the point of intersection of RB and SC. Prove ASTI are concyclic. Yes. Now we get to the question part. Now we get to like the main point of this problem, why I took this problem. Okay, let's have a better diagram here.
Wait, what was the definition of RMS?
Yeah, wait, let me. There are the points such that we have parallelograms. So this is A, B, C. Wait, let me just, what's the labeling? Q. R is a point such that AQRB is a parallelogram. So you have this, you have this. So R will be right here. This is a parallelogram. And S is a point such that, no, this is P. S is a point such that APSC is a parallelogram. So this will be S. Right? Uh, yeah. And so what is T? T is the intersection of RB and SC. So like here, T and I. And what do you want to prove? Hmm? R, S, T, I are cyclic. R, S, T, I are cyclic. Okay. Mm, let's think about this now. Yeah. Okay. So first of all, just direct, like, do you think you can compute T by complex numbers? Like, how will you do that if you had to?
I mean, like R and S are simple. RB cap CS is
Yeah.
bad.
Like PQRS in this problem we have already calculated. T is an intersection of like two weird lines. That's bad. In general, like the only time you should be intersecting lines is when they are chords of the unit circle. And they have a formula which we'll get to. So T is already bad. But after that, we want to prove that T, I, R, S are cyclic. So T is a bad point. And then we
But we
want to
have
prove,
three good points, right? One bad point, three good points.
yeah, but computing it is bad. And then you have to prove the cyclicity. That's also like very bad. Like T will be very bad. Like both these lines are horrible lines. Let me just get that here.
I mean, okay, I'm not sure, but I think I is the Mikhail point, and there was some
Yes, you
spiral
are correct.
similarity
We are
thing, right?
getting there. We are getting there. We are getting there. Yeah. So the point is, like, bashing isn't about like taking a problem and then just computing all the points and finding it. Like the best, if you want to be like good at solving geometry problems, you need to use bashing and synthetic together. So like the idea here is like what you want to notice is that prove like computing t like directly is like a horrible idea. But how do I best motivate this? So yeah, let's just say it. Let's draw this. Let's draw this. Oh God, this is hard. Well, yeah. Okay. If I had a better diagram, this would be more clear. Trust me. So okay. Second tip in complex problems, please draw like a perfect diagram and like get observations because bashing the whole problem is often very hard, but it's very easy to bash like small claims. And like so you can either like bash small claims and then finish synthetically or like do some synthetic observations and then bash for the finish. I mean, okay, it is advice for geo in general. That is true. Draw a perfect diagram. But I'm saying it still applies to complex. Like, don't think that, okay, I'm gonna bash anyway, I don't need a diagram. Because if you get some intermediate observations, that will make bashing very easy. So you can I like and there's other ways to motivate this. I'll just go with the good diagram motivation. If you had a good diagram, uh, you would notice that the triangle IRB looks similar to the triangle ICS. So IRB looks similar to ICS. So two questions. First of all, can you prove this observation using complex? And how will you, if you have this observation, how do you finish? This is probably could have motivated that better, but assume you noticed that in the diagram. So first of all, how do you prove two triangles are similar in complex numbers?
Showing that the angles are equal.
By showing?
That the angles are equal. That's
Are you saying angles?
yeah, angles. Yeah.
Angles. Yeah. I mean, you can do angles, but and yes, there's a determinant. But like, what you really need to think is okay. Just uh, yeah. Wait, the determinant formula comes from what I'm about to do, and angles are fine. So angles will be you're using AA criteria. What other similarity criterias are there? We have like we have SSS. The ratios of sides are equal, and SAS, two sides and like the angle between them. These are the three like ways to prove triangles similar. So using angles in complex numbers is well bad because how do you get them? There are ways, but like in general you want to like avoid doing just angles
I
unless it's
mean,
like you want to prove 90 degree.
all the lengths are well known because IRV are good points, so we can just use SSS.
Yes, okay. SSSs you can also use SSSs, but so if you want to do it in complex numbers, how will you find the ratio of like side lengths? Hmm. How do you find like the ratio? And like it's very possible to find it. Akshay? Like just divide the complex numbers, right? Say I minus R divide by I minus C. And this ratio of complex numbers, its magnitude is the ratio of magnitude of I minus R and I minus C, right?
Okay, yeah, we have to take the magnitude.
Yeah,
But
but
magnitudes are also hard to think about, right?
yeah, but okay, the point is you can multiply by the conjugate. Like magnitudes are
Yeah,
like you
yeah,
take the
yeah.
square, you multiply by conjugate. And since everything, like the reason we take everything is on the unit circle is because taking conjugate is just taking the reciprocal. Like 1 by A is the conjugate of A. However, when you take magnitude, what information are you losing? Like ratio of complex numbers, it encodes two pieces of information. One is like the ratio of lengths. What's the second piece of information?
The angle.
Angles. This already contains all information of SAS. It has the ratio of the side lengths and the angle between them. Right.
Yeah, yeah.
Oh, so we don't need the magnitude. We just do normally.
Yep. So when you want to prove two triangles equal, you can just set like I minus A by I minus B equal I minus what's corresponding to our C by I minus S. And that's how you prove triangles are similar. This fails when the triangles are similar in the opposite direction because angles in complex numbers are like different whether it's clockwise or anti-clockwise. So here you can notice that like IRB like are in clockwise order and so are sorry anti-clockwise order and so is ICS. If they were in opposite order, then you would want to take the conjugate of one side to make the angle negative. But here it doesn't matter. In any case, now every single thing here has a very nice formula. And when you plug that in, these two just become equal. Do some cancellation, do some maths.
Wait, how did we get
Hmm.
RNS again?
What?
How did we get RNS?
Oh, R and S are like points on a parallelogram, right? So parallelogram, the midpoints are same. So A plus R equal Q plus B. And we know QB and A
Yeah, okay, makes
by
sense. Yeah.
R. Yeah. And this will prove you the triangles are similar. And once you have the triangles are similar, what do you notice? If you have a triangle and then you have another triangle similar to the first triangle and they share a common vertex, what does that mean? Okay, maybe I should have drawn triangles that actually look similar. Okay, let's draw triangles that look similar. Yeah. Yeah, these look similar, right? And they don't look like they intersect at a vertex, but that's a minor point. If you have two triangles that are similar and share a common point, what does that make you think of?
Spiral similarity.
Yep. So like at this point, you can do a rotation that sends like this circle, this triangle to this triangle, like rotation plus a scaling because they're similar. So in fact, I is the spiral center of that sends BR to CS, right? Everyone with me?
Yes.
Wait, can you
And
repeat?
I is the spiral center that sends BR to CS. Sorry, RB to CS.
Yeah, yeah.
And what do you know about spiral centers? If you have, say, XY and PQ, how do you find the spiral center that sends like XY to PQ? Let's make it quick.
Connect
We,
XP and
yeah,
YQ.
Connect XY to PQ.
and then take like the big circle, cap the small circle.
Yep. TXP cap TQY. The second intersection will be the spiral center, right?
Yeah.
So in this problem, RB and CS, they intersect at T. That means the intersection of circle TBC and TRS will be the spiral center. But the spiral center is IE. So TRS circle has to pass through IE.
Oh, that finishes.
Yep. So you have to use a combination of both complex numbers and synthetic. You can try to do it purely by complex numbers by finding T, but you can cut down on a lot of calculation by a few synthetic observations. And that will be sort of like the theme of what I'll try to do in this lecture. Okay. And the other way to motivate spiral center, like which I did when I was solving this problem, is you can do some angle chase, like RB is parallel to AQ and CS is parallel to AP. So you can find angle like the angle between the lines RB and CS is the same as the angle between line AP and AQ. And you can prove this angle is the same as this angle. So this angle, sorry, this. I mean, you can prove BITC is cyclic very easily, and you'll be like, oh, BITC is cyclic, and I want to prove RITS is cyclic. That means I will be the spiral center. So I just prove it the spiral center by complex numbers instead. Okay? But like you can, or you can like the easier motivation is if you have a good diagram, which we didn't hear, but minor issues.
We can prove like RVCS is cyclic and then like names or something.
Hey, we do want to use some complex numbers, right? Like if you want to solve the problem fully synthetically, then you're in the wrong class. There will be a probably synthetic geo class will happen.
No, we'll do that using complex.
Ah, you amazing, amazing, amazing. Okay, what next? Hmm. Okay, let's do this one. This is a nice one, and this does not use any new formulas, and I'll give you once again. The idea is you want to make some synthetic observations and some complex. And for the rest of the problems, I won't do the full calculation. I want you to figure out what you'll calculate and tell me like if that will be like easy or not. Uh, yeah. Okay, so I'll give you peak. Yeah, because the class isn't to do. But if I start doing full calculations for every problem, we'll be here for a few days. And as jobless as I am, I don't have a few days. I'm guessing the Ohm didn't make me do anything. This class I spec yes. I'm not being only complex bash app Wait, who currently is controlling the OMC account? I don't know. Let me guess. Wait, there are only two people? I don't know. I thought all directors have access. I have DM'd you my guess. Wait, there are two OMC accounts right here. Bruh. What the hell? Okay. Nah, this class is too popular. Wait, Sanjana's also. Wait, how many? Is this class like all the directors watching me struggle to bash? Who? Huh? Okay, now I feel. Yeah, this is awkward. Okay. While I have been yapping, while I yap, guys, you should try the problem. This is definitely not the, yeah. I definitely did not put, I'm definitely not just choosing problems I have bashed to make my life easier. But the next problem you'll do, I have not actually solved, like synthetically or by bash. So that will be fun. Sure, surely nothing can go wrong. I'll, I'll put it there in case someone wants a buffer. I have not actually solved this. I have been told that this is complexable. I things can go. Guys, come on. Isn't watching someone bash in real time the most fun you can have doing math holly? Like what can possibly be more fun? That's supposed to be. Okay, I really wanted to use RMO 25P3 as an example, but I decided against it because really you should not be bashing it. I'll be completely honest with you. Please don't bash that one. Please just solve it. Most fun, thank you. And I do want to do this at some point. Bro is borrowed complex to save himself. Look, I realized my first problem cannot be anti-bash, so I bashed it. Okay, I'll post. This is a problem that's another problem I have not bashed. Surely it will be fun. Okay. Yeah, so
To
these two
solve the
problems I have
fourth, to solve the fourth
what?
problem, surely complex version is not the way, right?
Fourth problem. I was told it's like very instructive for Bash. That's why I brought it here. I have not solved it, like either by Bash or normally. These are the two problems I have not bashed myself. So they will be fun to do in class for the first time. Nothing can go wrong. I guys, can someone send me the solution on DMs, guys? Anyway, okay. So I've given people enough time. Any ideas for this?
Bro, I just finished drawing the diagram.
Draw the diagram. Yep. That's a good first step. Let us draw the diagram. Why? I keep forgetting that I have better ways to draw diagrams. This. And I keep using my trackpad. ABC. How are they defined? A1, A2 on BC on outside B and C. This is important. Please, I'm not throwing shade at anyone here. Do not put them inside the triangle. Is that A1B equal AC? A1B. So this equal this. Is this some kind of reference? Don't worry about it. Just don't worry about it, okay? You can. There's absolutely nothing of relevance here. I hope I'm labeling these correctly. And which is this? I think this is A2. This is B2. This equal this. Clearly, no one was trying in the other way. Yeah, like, of course, no one was. Like everyone like drew the diagram correctly, and everything was fine. And this did not have consequences down the line. No one made mistakes, guys. And especially no one definitely did not just draw A1, B1, and C1 and not A2, B2, and C2 and completely missed an observation. That would be completely crazy, right? Like not drawing the full diagram. Who could do such a thing? Anyway, so I hope you're okay. These lengths do not look equal, but I hope you guys have a well, yeah. So okay, any ideas, any observations, anything that you have noticed? That's how you make it into team. No. Not everything I say here is about people who have is about myself, guys. Come on. I have noticed my diagram is wrong. It's good to notice that first 5 minutes into the problem and not in the last 30 minutes of last how many minutes? I don't remember. Yeah, it's good to
30,
notice
30
that
minutes from
now.
the end.
30 minutes from the end. Yep. That yes. That's good. The amount of shade, bro. Like this is bad. I feel bad.
It was definitely like very bad.
It was
If you would noticed it earlier, he would probably made team.
and why it's fine. I know. We don't it's all fine, guys. Anyway, what's the first thing you notice?
C is on perpendicular bisector of A to B1.
What's the perpendicular bisector of A to B1?
C lies on it.
Oh, C lies on it. Yeah, a bit. Yeah, the triangle is isosceles, so C lies on it. Okay, correct.
Oh,
A to B1, and
oh.
is there any other perpendicular bisector C lies on?
B to A1.
Yep. 3 plus 1 is 3 plus 1. We are correct. And can you say something else using this?
Uh,
A to B1 parallel to A1 B2.
oh.
A to B1 parallel to A1 B2. Correct. Because, yeah. But something something else. Can you also notice something? Yeah. That's correct. The parallel observation is correct, and I'll
It's
mark it
an
down with a.
isosceles trapezium is also.
What?
A1 B2 B1 A2 is an isosceles trapezium. So
Yep,
cycle.
exactly. So it's an isosceles trapezium, and all isosceles trapeziums are cyclic.
What is an isosceles trapezium?
Uh, like there's only one pair of parallel lines. So B1 A2 B2 A1, like
Oh,
lines are parallel and diagonals are equal, which is what you need for isosceles trapezium. You can also like prove it by angle chase, like this angle equal this angle, whatever. Yeah. So what cyclic quadrilateral do you get?
A to B1 B to A1.
Yeah. Okay, fine. I wrote this in this order.
Right.
I'll, yeah, anyway, or I can just write it as A1, A2, B1, B2. And by symmetry, you will have a few more cyclic quadrilaterals. B1, B2, C1, C2, and C1, C2, A1, A2. Uh, do these three cyclic quadrilaterals make you think something?
and they all the same. Wait, no, they're not.
Yeah, but why are they all the same?
The
Why can't they
circle
all
is
be
the
different?
same.
But why? Why? Yeah, okay, Namish has the correct idea, but okay. What do you do when you have three circles? What's a common thing?
Radics, rad
Radical
point,
center.
Radax. Yep.
center.
Yeah,
Oh,
radical
okay.
center. So the radical axis of the first two circle is what? B1, B2. That's AC. The second two is C1, C2. So AB. And the first and three is BC. So AB, BC, and CA concur. That doesn't sound right, does it? What went wrong?
Turns out they're the same circle, so you can't
They are the same
mix.
circle. Yes. That's how you prove it's the same circle. And this is also like a common trick. Like surprisingly, it comes up like multiple times. That if you have like three cyclic quadrilaterals, each of which share 2 points, and you want to prove it's one big cyclic quadrilateral, you prove their radical axis don't concur. So you have one big cyclic quadrilateral. And then you remember that we are supposed to complex batch this problem. So what are we doing? And finally, what are we even supposed to prove? So orthocenter of A1, B1, C1 and A2, B2, C2 are equidistant from the circumcenter of ABC. Right. So we want to prove two distances equal. Now, so we have like H1 and H2, and we want to prove OH1 equal OH2. So like, of course, like the way you will do that is you will square both sides and like write it as OH1 times conjugate, OH2 times conjugate. And so you think if you want to complex batch this, you'll obviously set O to be the origin. So you'll do like H1, H1 conjugate equal H2, H2 conjugate. But I mean, the question is, how do you find H1 and H, right? So before finding, like, so H1 is the orthocenter of A1, B1, C1. Can you find A1, B1 or C1? Or like, if you can either think backwards, or if you have some further observations, just say them. That's also fine. Both methods work.
Maybe those two circles share the same center. That might happen. ABC and even, but then
That's a good that's a possibility. We can think about that, but
based on your reaction, that's not the case. So
yeah, based on the reaction. So yeah, it's indeed not the case. But the center is a good idea. Thinking of like the circumcenter of this big circle. How do you find the circumcenter of a circle generally?
Intersection of perpendicular bisectors.
Intersection of perpendicular bisectors. Indeed, indeed, indeed. And wait, like remember we were talking about like how C is on the perpendicular bisector of B1, A2. Can
Right.
you say something? Can you say something more about the perpendicular bisector of B1, A2?
It's the angle bisector of ACB.
Yeah.
So the
Perpendicular.
center is the center.
Precisely, yeah.
Yeah.
Perpendicular bisector of isosceles triangle is the angle bisector, which is also the angle bisector of this. And so all perpendicular bisectors pass through the incenter. I is the circumcenter. This is a really simple way we have proved this, right? Surely no one would have used cosine law and barycentric coordinates to prove this. Surely no one would do that, right? And surely that person would not go on and make team. Surely. Yeah, so like I proved this by like bash because that's just who I am. Also, here's something I'll do to quickly make. Here's something that almost like no one found for some reason. So this is I, right? Uh, what is this length? Like, so this will be like B, suppose. What's the length BD? Like the distance from B to the encircle touch point.
S minus AC.
S minus B. Yeah.
S minus A. Like like
What?
sorry, S minus B. I apologize. And this length, this is same as BC, AC, that's B. So this whole length is S.
Yeah.
And this length is R. And this angle is 90. By Pythagoras theorem, IA1 is R square plus S square, square root. We didn't need anything. All these lengths are I square plus S square, square root. Like I was equidistant. We didn't need to do all the angle chase. This was just cyclic with center I.
Can you repeat this last thing?
What's I A1 is ID square plus A1 D square. That's R square plus S square. That's a constant. Like that does not depend on whether we had picked A1. If we pick C2, we will also get IC2 equal R square plus S square.
Oh, right.
And
Okay.
I know we usually define cyclic quadrilateral by angles being equal, but a circle is actually the locus of point equidistant from a common center.
Yeah, but you need to get point. You need to know what the point is.
Yeah, okay. So, like, for other people who angle chase, this is fine. In contest, I drew a perfect diagram. I noticed I is the circumcenter, and then I Barry batch to prove the lengths are equal. My motivation came
Barry
from a
Bash.
diagram. I didn't go like this way, like this natural way. I don't know what I was doing. I used barycentric coordinates along with cosine law. Like, even normal barycentric just works. I didn't have to use cosine law. I was just cinematic. Cinematic. Anyway, now we have a now we have A1, B1, C1. Like we have a big circle and we know its circumcenter. Now we can start thinking about orthocenter. So look at triangle. So we have triangle A1, B1, C1. Yeah, even just cosine works. I don't know why I used both cosine and Barry. So the circumcenter is I, and we want to find H1, right? Because calculations. So now is the part of complex bash. That was all the synthetic we are getting. So, how will you find H1? Give me a strategy.
You can try to find A1, B1, and C1 first, because that's
Okay.
doable.
Good as ideas any. How will you find A1, B1, C1? We won't actually do any computation anymore. Just tell me how you will find them.
What are you taking as unit circle?
Oh, good question. It's up to you. What choice do you think will be best here?
You just gave a way to compute A1I, right?
What?
Like from what you said, we can compute A1I.
But we already know A1I. It's R square plus S square.
So we know I as well. So can't we compute it that way? Or no?
Okay, for what do you mean? Like, we know the length, but how will we get the complex coordinates of A1 then?
The
Like,
direction, I'm not sure if you can get the direction that way.
Uh, not just the direction. The fact is like you don't want to leave it in terms of like r square plus s square square
Like the
root. You like
intersection of
ideally want
BC
you
with
want
that
it in terms of
circle.
a, b, and c. What?
The intersection of BC with the circle.
BC with the circle, but first of all, there are two intersections. So you'll get like a quadratic equation, and then you have to decide which route to take. That's always bad.
I see.
Second, like random line intersect with random circle is usually not a good idea.
So you can take BC and then we know the length CA1, right? So you can multiply
Yes.
BC by that.
You know the length. Wait, you know the length CA1. You multiply BC by that. Perfect. Yeah. Okay, okay. Okay, no, that's not perfect. But you are getting there. So the length you have this length. So you want to so what you're saying is like take B. So take like C, like take the vector CB. So sorry BC. So B minus C. Like divide by B minus C and multiply by like the A1C length.
Yeah,
And like okay, then you add C and then you this will be A1. Right.
yeah.
So and like this is BC. Okay, but
Wait,
lengths
what
are
did you just do?
so what he said is like take like look at like B, so B minus C represents this vector like that originates at C and ends at B, right?
Right. Yeah.
So you divide by the length BC to make it a unit vector,
Okay.
and then you multiply by length A1C to make it the vector from C to A1.
Oh,
So like the coordinates of A1 will be this vector plus C.
Okay. But isn't the plus in the other direction? Like, not.
No, no. So like, so suppose you have origin somewhere. So this will be like the vector c, and this will be the vector. So like, you want c plus a1c to get a1, right? Triangle law.
Right.
Like you can think of it as since you have subtracted c here, so you have to like add it back. Like you shifted the origin to c by subtracting c, and now you shift the origin back by adding c.
Yeah, okay. I got it.
Yeah. Okay. So this is a good idea. The thing is, just like lengths are bad. Like squares of lengths are very good. Like x times x conjugate, you can do a lot of things with that. Just lengths, you would have like square roots involved and stuff. So that's bad. But you can get around this. So think like you're in the right direction. You want to think about like the fact these lengths are nice, but do something else.
We know the in what ratio B divide A1C.
What? B divide A1C. Yeah, okay, once again, so you're saying using section formula, right?
Yes.
But section formula will also involve like this, like magnitude BC, magnitude magnitude A1B, and just magnitudes of length having in that formula is bad. Like if they're square, it would have been fine. But without squaring, this just having them in an expression is bad. You want the coordinates of every point you are computing to be like just like a simple expression in A, B, and C. You don't want like square roots involved. You want it to be algebraic, ratio of two polynomials. No, rational, not algebraic. Algebraic will have square. You want it to be polynomial or ratio of polynomial. I got it right the third time. So, circle diameter one. Okay, once again, intersecting random circles is in general a very bad idea. You don't want to intersect circles, like as far as you can. Okay, so I'll tell you, you don't want to like explicitly have a length involved in the formula, but the lengths are still nice. So what's the other way to use lengths? I mean, what's the other way you can use the fact that A1B and AC are equal without like using section formula or something?
And you can rotate AC. Like, yeah,
Yep.
you can put
So
it
the
on.
idea is you rotate AC to be like aligned with BC, and then you add it to the point B, and that will give you A1. So you never have like you use the fact the lengths are equal, rotate AC, add it to B. How do you rotate AC? You want to rotate AC by an angle of C.
Just divide the two. If you divide C minus A and C minus B to get the argument.
What?
You divide C minus A and C minus B to get the argument.
C minus A and C minus B, but then you have to extract the argument, right? Like when you divide C minus A and C minus B, you still have the lengths involved. You don't want to have to like divide out by the lengths. So I'll tell you something. We already have an incenter here, right? So we like already want to be taking stuff as A square, B square, C square. Because we want to like write incenter as minus AB minus BC minus CA. Right. Just just putting it out there. Take C as origin. Yeah, okay, C as origin is fine, like for rotation. But the thing is, okay. Yeah, take C as origin. You'll subtract C square from like C or C square, whatever. You'll subtract it from everything. Now you have a vector AC. You want to multiply it by like e to the I theta to get the vector what a1 b. Yeah, a1 b. My question is, how do you get this e to the I theta? Like, sure, AC is fine. AC will just be like A minus C. So let me just write A1 equals C plus A minus C times E to the minus IC, or sorry, plus IC. It depends on which direction you're taking the angles in. Plus, like, not matter. How do you get this? Take the foot of A on CI and reflect A about it. Add B minus C to this. Oh my God, reflections and like. Look, we only want to get the like E to the IC. And like C is a natural, like, do you really think we need what? Wait. Take the foot of A. Yeah, okay, reflections are nice and complex. You are correct. What are you doing? Wait. Take the foot of A on CI and reflect A about it. Wait, okay, so you're just saying reflect A about CI. Bro. Ah. Oh, okay, that's actually like clever. That's not what I was gonna say, but yeah, that's clever. That actually does work. Okay, we'll go with that. Okay, so I'll explain what you're trying to do. Let's, I don't know why I didn't think of that. Okay. And that means I do have to explain the reflection formula, which I have not yet. No, it doesn't matter. Okay. Okay, so what Namesh suggestion is, so we want the vector AC rotated to be like aligned here, right? But wait, okay, let's make the triangle look less isosceles. It still looks isosceles. All triangles look isosceles. Okay, oh no, but we can. Aha, this is how we fix it. We take this to be B. And now we have to rotate AC to be here. And this is clearly not isosceles. Anyway, so we have the angle bisector. So what Namesh is saying is you reflect A about the angle bisector. And that will lie on CB. And you'll get some A dash. And these lengths will be equal, right? So this is in fact like the CA dash is the required rotation of CA. Does that make sense?
Yeah.
Yep. Yeah.
Yeah. And his point is, okay, so this is this line CI. And CI meets the circle again at minus AB. Right, so this is A square. This is B square. This is C square. This is minus AB. But yeah, minus AB. Yeah. So you want to reflect a point about a chord of the unit circle. This in general is like a very nice operation. And so I'll mention like the two formulas that I have not mentioned yet. The one you need to remember. So if you have a unit circle, if you have a point A, B, C, and D, then their intersection, first their intersection is AB times C plus D minus CD times A plus B divide AB minus CD. And like the way I remember this is if AB and CD are parallel chords, their intersection should be infinity. And if AB and CD are parallel, that means AB equals CD. That's why there should be a AB minus CD in the denominator. And the second thing is if like they are both diameters, their intersection should be origin. That's why there is like a plus B here and C plus D here. So if A was minus B and C was minus D, this would become 0. That's like one way to remember it.
Why is it
So
asymmetric
that's
though?
what?
Why is it asymmetric?
It's symmetric. There's a negative in both denominator and numerator, right? So if you replace it, like you can write this
Oh,
as like
okay.
this.
Right.
You can just multiply by -1. Yeah. So this is the intersection of chord formula. That doesn't come up in this problem. I just mentioned it because, well, unit circle formulas are coming up. And the second formula you need to know is okay, foot of perpendicular and reflection. Okay, so can someone just tell me the formula? Who remembers?
Do we assume ABC as the unit circle?
Yeah, assume ABC is a unit circle. Or like, yeah, if A, B, and C are 3 points on the unit circle, what is like the formula of foot of A and the reflection of A? Well, if you can tell me one, you got the other, right? Because if you know the reflection, you can take the midpoint. If you know the foot, you can take the reflection.
Yeah, the
Like
foot is half of A plus, sorry, B plus C plus A minus BC A conjugate.
half of B plus C plus A minus
Half BC A conjugate.
B C A conjugate. My mistake. A can be like not on the unit circle, right? Yeah. B and C are points on the unit circle, and the reflection of any random point A is given by this. Right? Half B plus C plus A minus BC conjugate. And no, this is the foot of this is the foot of A, sorry. And the reflection is given by B plus C minus BCA conjugate. This is the reflection of A. And B and C are on the unit circle. A doesn't have to be. Yeah. Okay, so like these are like so the formulas you need to remember in complex are intersection of chords. Remember either reflection or foot and orthocenter and center. You can basically get away with only knowing this. Like if anything requires more, then like don't do the problem with complex. Anyway, yeah, so I won't do the actual computations. I just wanted to tell you the formula. But like, yeah. So what you do is you have a square, you have a chord of the unit circle, you apply this formula and you will get a dash. So you have c a dash. Then you do the translation by b square minus c square to you, so you will get the point here, a1. And similarly, you get b1 and c1. So you have the whole triangle a1, b1, c1. And this computation, like, even without doing, you can see it won't be hard, right? The reflection formula is very easy. Like, what? B plus C minus BCA conjugate. And then you have to add something. So you can get triangle A1, B1, C1. Now, how do you get orthocenter from there?
Sum up.
What?
Maybe
Yeah,
this
I mean,
is the same thing, right? Because we know
We
what
we
I is.
know this circumcenter and we know like their centroid, so we can get
indeed.
orthocenter.
Indeed. Orthocenter you can get right as 3 times centroid minus 2 times orthocenter. Centroid is just like 3 times centroid is just A1 plus B1 plus C1, all of which we have found. And that's minus 2 times in center. And in center, this will give you H1. And this is also nice. So like the only part of the problem you have to do any computation in is computing H1 times H1 conjugate. You don't have to even compute H2 times H2 conjugate. Like once you compute H1 times H1 conjugate, you just say this is symmetric in ABC. So H2 conjugate will be the same thing. Hence we are done. And that works. Does everyone understand?
Then why do you even compute the first one?
Which one? Oh, no, no, no. You don't know before computing that it will be symmetric, right? Like, since the problem is true, the answer will come out symmetric.
Oh, okay.
But, so like, that's why I'm saying, like, after you compute it, you can say it, but, well, you have to compute it to prove it's symmetric. Like, all you can say that it will be cyclic. Like, A1, B1, C1, like, and A2, B2, C2, like, are, like, cyclically different. Like, whether you take triangle, like, in this order or that order. So, you'll get the expression that's, like, cyclic. You will also notice it's symmetric, hence it will be the same as this. Anyway, is this problem clear to everyone?
Yeah.
Is there also? Yeah.
Oh
Okay,
no, I
Rudransh.
just said yes, it was clear.
Yeah, Rudransh. We don't have to like. I know the triangles are congruent and you can synthetic it that way. Like, but no one cares about synthetic in this class. Okay, like, I know you can. I know it's possible. And actually, like a bunch of nice ways to do it. Like you prove that these three lengths are equal, hence like there's a rotation, but no, we are not getting there. Anyway, what I was trying to do, like this reflection is a very nice idea. Uh, what I was going to do is like this, right? We want to rotate, like we want to find the unit vector that has an argument of c. So I'll just mention this because good trick to know. Yeah, a square, b square, c square. So, okay, so like taking the ratio of these two sides is bad because you get like an extra length term. Right. So you want to take ratio with O because then these two have like the same length. So when you take the ratio, it's already a unit vector. But the issue is this angle is 2C. So, well, you know the Archimedes point, right? Minus AB. This angle will be C. So minus AB is one unit vector, B square is the other unit vector. So you take their ratio, and that will be the thing that rotates by angle C. Is that clear?
Yeah.
Yeah. You can also do this, but reflection maybe probably a neater idea. Why did I not do reflection? Anyway, oh, we are approaching the end of time, and wait, where are the problems? This
Okay,
is
now the
one.
problem you haven't done yourself.
I really want to talk about IMO because this actually like is about like how you make your life easier. But fine, how about okay, we'll try this and then I'll do IMO. Okay, we won't be getting to the last one. That's complex bash class 2. Someone else will take. Okay, so this is P2, this is P3. Okay. uh yeah, sure, let's try this. Oh, how do I select? Let's take this down so a bit below. Okay, bashing in a crowd is bad. Okay, everyone try this while I'll try this on my own notebook so you don't, just copy my work. Let's everyone try this for 5 minutes and then we'll discuss ideas. When complex batch class 2. Whenever the dictators like I can't believe I managed to get this class permission. Guys, you need to rate this class highly. Like just go in the Discord and say yes, best class, best class. So they want to do another complex batch class. Are the dictators still here? Are they listening to what I'm telling you to say? Shit, they're here. No. Give honest feedback, guys. Honest feedback. I'm not bribing you.
It's fine. Both the directors here are pro bash.
Thank you. Okay, ABC problem. Okay, and so one thing I'll mention maybe, but like, where is this? Where was that formula? Uh, What? Yeah, and in this formula, if you put like A equal B, then you get like the intersection of tangent at A with CD. And if you put both equal, then you get the intersection of like tangent at A and tangent at C, which is, clear, but like just worth mentioning. I'm mentioning that because I feel it might be relevant in this problem. Okay. Surely this problem can't be hard to bash, guys. Surely. Bro, I have already messed it up. The diagram is wrong. BC reduced beyond C. Bro, the diagram's so wrong. I'm also extremely hungry. That's the different issue. Admits encircle. Yes, admits, guys. The quadrilateral is admitting. The GB a point on line AB. FG is parallel to C. Ah. Okay. H be the point such that EH is parallel to. Wait, what? H on. Wait, am I doing something wrong? Okay, the problem has weird asymmetries involved, which is fine. Let's prove that EFGH admits. Yeah, okay, so if ABCD admits, EFGH admits. Oh, this. Well, the diagram is not that horrible. It's indeed a concave quadrilateral. Hmm. Admits an external tangent to EG. Wait, what? Wait. EG. Wait, what's the quadrilateral in order? EG FH. EG. Oh, bro, I drew the wrong one. Okay, so I want this. Tangent to EG EH. FGFH. Oh, this does not seem that hard. Oh, okay, I see why this is. Wait, never mind, I forgot. Okay. Hey, the calculations are bad. What? I'm like surely G and H are like E, F, G, H are like all findable.
Uh, for G and H, the calculations are bad.
Oh, surely wait. Okay, let's draw the diagram here. Okay. Oh, why do I have things on Discord?
But how can the X circle even exist? Like I can't even
Mm,
diagram showing.
okay, let me make a thought of it. Let me make the diagram here now. It's been long enough. Okay. So, oh, I see what you mean about them being bad. I forgot ABCD is not the unit circle anymore. Minor issues we'll deal with. So, oh God. Okay, I'm not drawing with. Okay, let's figure out how to draw this diagram. No diagram. No. You guys draw a diagram, please. Drawing diagram is too much for Aadish, guys. Okay, this looks fine. So A, please tell me I got the labelings correct. A, B, C, D. There's where's the X circle is of E, F, G, H, right? Yeah, A, B, C, D has an in circle. Guess so. I did not misread the problem. E, G. Oh, this is F. Yeah. So this is A, B, C, D, E, F, right? Now G is the point. So like take the line from F parallel to CD. So this is CD. You take the parallel Oh, what? This is not parallel. What the? So this is parallel and extend it with AE. Yeah, good enough. I'm going against my own commandment of draw a perfect diagram because, guys, come on. This will be G, and then you draw the line through E parallel to AD. See, this is the weird thing I didn't like about the problem. Like from E, you're drawing to AD, while from like the one that's further away, but from F, you were drawing the closer away one. But whatever the problem says, I shall do. And this is H. And then you have E, F, G. No, yeah. You have E, G, F, H. E, G, no. E, G, F, H. Okay, yeah, this quadrilateral. Yeah. E, G, F, H. Okay. And you want to prove it has a X circle that's like this looks like an arrow, so like an X circle here. Tangent to EH and EG and externally tangent to FH and FG. Okay, so first of all, how will you compute the points? Like A, B, C, D, E, F, G, H. How do you intend to compute them? Let's start with A, B. Okay, let's start with a simple fact. What do you think we should take as unit circle?
There is like only one circle in the.
There's only one circle in the problem,
Circles.
guys. Yeah, who would have seen this coming? So let's
No
mark
one.
this point. No, it's absolutely okay. This is W. This is X. Uh, okay, these are the tangency points. Even though the circle like does not even touch, like it's supposed to touch these lines. So W, X, Y, Z. Now, how will you find A, B, C, D?
Use the
and
tangents.
and E and F? Yep. We have already discussed like the intersection of tangents formula, like put things equal there. And like it simplifies a bit. So the intersection of tangents at A and B is 2AB by A plus B. You don't just compute them, right? What do you mean?
Like, why do you need A, B, C, D for anything?
You'll need it to find G, right? Okay, you need E, you need F. You will need, okay, you don't need all of them. You need two of them. You will need A to find G. Oh, wait, let me think. With which? With
I
CD
think
and
E
FH
will
are
be like
parallel.
2 into C minus A by A conjugate C minus AC conjugate. And for
What
F,
will
we
be?
need D and B, right?
What will be what?
E equals to 2 into C minus A by A conjugate into C minus A into C conjugate.
Hello. Okay, no. You don't need any weird things for E. E is also the intersection of two tangents, W and Y. Well, E and F are just two tangents. E and F you can just find with ZX and WY. You don't need to intersect random lines. Please don't do that. You have tangents. So, oh, by the way, this intersection of tangents formula you can also prove by inversion, which is fun. Anyway, yeah. Okay. Shreya might be right. We might actually not need any of these. But okay, the point is, if you want, you can compute. Like, we are just trying to see how you will like do the problem computationally before doing the computation. If you want, you can compute all A, B, C, D, E, F. I don't know how many of these you'll need. Well, we'll certainly need E and F because, you know, it's E, F, G, E, G, F, H. Why? Why E, G, F? Why not E, F, G, H? Anyway, yeah. Now, how will you get G? Yeah, shit. Like, I don't think you can get away without like finding A, B, C, D, right? To like find
Why
G,
do
you
the
will
CD is just the tangent to the circle at Y. So you can take Y and then rotate by 90 degrees.
you can take Y and then rotate by C, D is. Oh you want to find G like that?
Yeah, I mean, it's the
Ah,
tangent.
yeah. Okay, so you want to like take the line through F parallel to the tangent and intersect it with like this tangent. Hmm.
Yes.
I I'm sorry, where's the parallelogram, Mr. Synthetic Geometry? I somehow feel you will not be helpful to this class. But wouldn't it be like much like clean instead of intersecting like other lines? Wouldn't it be cleaner to do a homothety at A or like B? Because you know C, E, and F. So like you will have F
Okay,
minus B
true.
by F minus, right?
True.
Yeah, so that's why like I mean I think you can get away without computing like one of them, but you will need three. Yeah. Ignore the synthetic geometry propaganda. Yeah, so what I was thinking was since like look at A, since CD and FG are parallel, ADE is similar to AFGE. So like as we just did, right? A minus D by A minus C equal A minus F by A minus G. So using that you can find G. And similarly you can find H. These will be okay since like A, B, C, D, E, F are all very nice points. They will all look like this. 2AB by A plus B, where A and B range over X, Y, Z, W. So this computation is like fine, but now G and H are annoying. You but just getting it there, but it won't be hard to find. You can get it. Now the final thing is prove that EFGH admits an X circle. Okay, so Pitats, guys. Yeah, so how do you prove a quadrilateral has an X circle? Anyone? Pitats. Yeah. So that's one way. So okay. In circle pitats, it's like sum of opposite lengths equal. X circle pitats is difference of opposite lengths equal. Like you treat FH and FG to have like negative length, and you can do pitat. Um, sure, is that correct? I believe so, but someone had to check it. Okay, but okay, yeah, I see the issue though. But like, okay, there will be some version of pitat, so you will get like I think I'm not sure. You want to show EG. I think it will be okay. I'm guessing here. I'm guessing this should be the answer. But okay, the way you find it is like take the X circle and like see which lengths are like equal by using, you know, the stuff. But I, okay, I'll get to what I'm gonna say. Yeah, difference of opposite sides. EG minus FH equal EH minus FG. Like what you are doing is like normal pitats, but like it's externally tangent to FH and FG, right? So you say that FH and FG have negative side length.
Wait, so is the theorem both sided? It's not both sided, right?
Well, normal pitat is both sided, so I would hope this is both sided. In any case, whether or not this is true, the thing we need to really mention is it doesn't matter because we have difference of side lengths. As we have discussed countless times in this lecture, squares of side lengths are fine. Normal side lengths are like why would you do this to yourself? Like who hurt you, right? So Pitats is sort of a bad idea here, I would say. Any other ideas? What other ways are there of proving like something has a X circle or N circle? Well, some I say something but the quadrilateral. Like lengths seem bad here, like because these are not squared. Unless you can find a way to like somehow deal with that. Draw FGB and so EC is tangent. Yes. That is a way, but something symmetric in all 4 points. Well, okay, I say symmetric, it will be like slightly different for like FG and EF because of like where it's external. Like, something that looks reasonably symmetric. Yeah, some think. Well, your method might be the better one. As I said, I have not solved the problem. I think I know what to do now. I think I figured it out, but might be wrong. Okay, guys, how did we prove a triangle has an incircle? Let's go back to some basics. Oh, why is the mouse so big suddenly? How do you prove a triangle has an incircle? Trixie,
Angle
everyone's like
bisectors.
angle bisectors. Yes, thank you. Yes, Arnav is right. You intersect two angle bisectors, and the point is like any point on the angle bisector is equidistant from two sides. So the intersection is equidistant from this side, and this side, right? So what you want to do for a quadrilateral is intersect all four angle bisectors. Suppose you have a quadrilateral. If you want to prove it has an incircle, that's just saying all four angle bisectors concur. Because then that point will be equidistant from like all four sides.
But if three concur, then the fourth must
Yeah,
also.
if three concur, then you are done. Because if three concur, then like first concurring tell you its distance from side one is equal to side two. Second tells you it's side two to side three. Third tells you it's side three to side four. And by transitivity, you just get side one, side four.
Yeah, so all
you
of them
only-
will be equal.
Yeah. So you just want to prove there's a point where the three of the angle bisectors concur. Right. Now, what are the angle bisectors? Like that seems random, right? Well, you will notice something about this quadrilateral that while the points are like extremely random, FG is parallel to what do we call it? CD. EH is parallel to AD. GE is parallel to AB because GE and AB are same. And what is left? FH is parallel to BC because they are same. The sides of this quadrilateral are parallel to the sides of the original quadrilateral. Right? So even
Yes.
if the quadrilateral is bad, all the directions are very nice. Okay?
Wait, so can't you say that since the original quadrilateral has an incircle, then this must have an
Hey,
incircle?
what kind of scam is this?
Because they're parallel, right? So the angle bisectors would be just translate. Okay.
Even if the four sides are parallel, that does not mean that the quadrilaterals are same. That's same true for triangles, but
They're
like
not the same, but the angle bisectors would be same.
angle bisectors would be parallel. But they're from different points. You don't know they concur. Well, I mean, you can't just say that.
They're not they're not parallel, they're perpendicular into the external angle bisectors.
Oh yeah, also yeah, true. Since we want an X circle, we want some external angle bisectors, which will be perpendicular to the original internal angle bisectors. Yeah, good. Forgot about that. So you'll want internal bisector at F and E and external at H and G, and you want them to concur. And yeah, and Ahan has like a counter example too. Like, look at ABCD. If you like translate AB a bit, like extend this side and like consider this, then this does not like this extended quadrilateral. This does not have an incircle because like this circle's tangent to three sides but not the fourth. But its sides are parallel. So yeah, that won't work. But the idea is all all these directions are nice.
So you
Right.
take a point P, solve for PF parallel to XY and PH parallel to some XZ or something, and then take that point and show that other things are parallel as well.
Well, one more thing. You don't need to see. If you have three angle bisectors, you have the fourth.
Yes, one more thing.
So you like, yeah, so the idea will be like, I think E and F will be the easiest to solve for, and then you show like either G or H.
Right, how does it matter? Won't it be symmetric or something?
No, E and F are like nice points, and G and H are like disgusting points
Yeah, makes sense.
comparatively. So like,
Sure.
you only want to use one of G and H. Like if you can, so like that's how you cut down on your work. Like bad points, you use them as little as possible. Anyway,
Yeah,
what about
you
the
could
angle
also
bisector?
like instead of actually computing the intersection, you could take the equation of the line and then prove that the determinant of those set of equations is zero.
Oh yeah, take the equation of the three lines. That's also a good idea. But like usually in complex numbers, yeah, that's no, that will work. That will just work.
Yeah, I'm not sure though because the equation of the line itself is a determinant, so it will be a bit messy.
But no, you can't write an equation of a line without determinant. Like it will, like general equation of a line in
I
complex
mean
is like
like expand the
AZ plus BZ
determinant.
conjugate plus C. Yeah, yeah. This will also work probably. Yeah. Anyway, let's just think about the angle by. By the way, guys, what are the angle bisector directions? Like if we want to, like either method we use, we will need like the direction of the angle bisector. So let's think. Let me just say this. So look at angle bisector at F. That line should be like parallel to the angle bisector of, well, okay, we want angle bisector FH and FG. So that should be parallel to the angle bisector of BC and what's FG parallel to? ADE.
It will be parallel to XY.
So I
FG
don't
is
know.
parallel to CD.
What?
FG is parallel to CD. FG and AD intersect at F.
FG is par. Oh, FG is parallel to CD, bro. Yeah, yeah. Okay, yeah. FG is parallel to CD, and this is parallel to CB. Yeah. Okay, but
We
like
want to be perpendicular, not
yeah.
parallel.
Okay, so like the thing is, yeah. So the external angle bisector at C here will be
Right.
parallel to the internal angle bisector here, and like the external angle bisector will be parallel to XY by like just look at it, bro. That's the reason I'm giving. Yeah, so this will be parallel to X minus Y. Right, so you'll have F plus X minus Y. And similarly, the one at, hey, will they all be parallel, end up being parallel to some differences? That would be really nice. Like if one is some, one is difference, that would be sad. So what's E?
Z
E.
minus W.
I'll trust you on that. Yeah, it looks in the same direction. It's either plus or minus. Looks Z minus W is the correct direction. Okay. Um, G. But that looks wrong now. G will be EH, that's AD. So AD and BC. Oh, will that be Z minus X? Right?
Hmm.
I think so. And I think this will be Y minus W. Oh yeah, that looks surprisingly good. Yeah? Everyone fine with this?
Yeah.
Hard to-
Yeah, okay. It's Z minus X. Yeah.
Yeah. And okay, so given a point and like just let's just get this out of the way. I think determinant seems like the cleaner way. I mean, actually, you can do both. Like, so one idea is like set P minus C parallel to Z minus W. Oh, but everyone knows how to set lines parallel, right? I never mentioned it, but if you want to say like AB is parallel to CD, what you do is like you set the ratio to be like A minus B by C minus D has to be a real number. So you set A minus B by C minus D equal to its own conjugate. That's how you do something as a real number. And if you want to do perpendicular, then their ratio is imaginary, so you set conjugate equal negative of itself. That's fine. Anyway, given a point and the direction, how will you find the equation of a line? Anyone? Let's just...
And then you can say that for all points z that lie on that line, z minus f by x minus y has to be a real number.
Oh, yeah. Oh, that's... I was going to like say, oh, every point will look like f plus t times x minus y and then do some stuff to convert parametric to normal, but yeah, that's like much more obvious, bruh. Yes, so yeah, you will get yeah, so your equations will be like this. So you'll get p minus f by x minus y is real. Uh, p minus e by z minus w is real. And compute one of h and g. Like you do have to do some computation. P minus h by z minus x is real. You take these equations, when you simplify them out, they will all become like a times p plus b times p conjugate plus c equals 0. And you want the three equations to have a common root, so like set the determinant 0. The classic stuff.
Wait,
Is that clear?
setting that determinant.
Oh. Oh, okay. Should mention that maybe. Like if you have three equations like ax plus by plus c, a2x plus b2y plus c2, a3x plus b3y plus c3, then like the determinant whose entries are a1, b1, c1, a2, b2, c2, a3, b3, c3, that has to be 0 for the equations to have a common root. So like treat p as x and p conjugate as y.
So they're just scaled up versions of each other. That's what that's what you're trying to say.
The line should be linear combinations of each other.
Okay, yeah, makes sense.
Yeah, exactly. Anyway, so I won't do the computation, but judging like, okay, E and F are very nice points. So these two equations will be like relatively simple. H is a bad point, so this will be a bad equation. But that's like, so you have just one set of bad coefficients in a determinant. And like, if you are clever with determinants, like if you find some factorization, which I hope exists, it won't be too bad. So this computation will be like more disgusting than the ones we have had so far, but this won't be as bad, and it certainly will be like less bad than like trying to like square root of a eg conjugate and then trying to find the lengths. Okay, I was actually able to do a problem that I had not done.
Is there any way to deal with configuration in such questions?
Config issues.
I'm not sure, but how do you know for some other configuration the parallel thing doesn't end with perpendicular and stuff?
No, but the thing is, they have given that you are extending beyond D and C and beyond B and C, right, in the problem. So I don't think that will come up. Like
Yes.
AB produced to be on B, DC produced to be on C.
Okay,
So
makes sense.
I think the diagram will always be like this.
I see.
I certainly hope. Anyway, so yeah, that was a nice problem. Yeah. So yeah, so this is like few tricks. For once again, lengths are bad. And so like you want to concur lines. And yeah, so if you have encircle, then you like take the encircle as the unit circle and define points as like tangents, whatever. Okay. Okay. We are already 20 minutes over time, but I do want to discuss the IMO problem. For no other okay. I mean, okay, fine. I'll do it quickly. Propose by oh, by the way, I didn't tell sources, did I? What problems? So this one is this year's practice TST. No, sorry, this year's TST P2, and this one is some. I think this is some practice TST. I don't know remember which one. Does anyone know which practice TST is this? Yeah, it's a P3. This was a practice TST P3, guys. of which year is this? 2024? Was this an art practice TST, Shreya?
Which year? Like which day?
Day 2 P3.
Okay, I don't know. I didn't give day two.
I didn't give day 2 either, that's why I'm not sure. I was like, I left day 2 in like 10 minutes. I was sick. I don't really remember P1. Yeah, this is practice TST day 2 P3. So, okay, I didn't know it was a P3 when I took it. I just took it. Yeah, so learn complex bash, guys. You can solve P3s easily. Well, okay, not easily, but you'll also see like the fact that computation is disgusting is not that bad since it's a P3. Like solving it synthetically will probably be like even harder. Okay, that's I solved the P3. Damn, I thought it was P2. Okay, now IMO P2. This is IMO 2025 P2. The only reason this is an example here is because I bashed it at the IMO in contest. And everyone else on the team synthetic did. At coordination, Rijul was told by the arbitrator and the coordinator, whatever, that all of your team, like I had to check such horrible scripts before this, and the entire team India, I'm so thankful to them. They have written such nice clean synthetic solutions, except India 1 does not seem to be that good at geo. So this problem and me have a history. So let's yeah, so this problem is also famous for the fact basically any synthetic trick you try in this problem will work. It's impossible to go down the wrong path in this problem. So we will go down the one path that can possibly be classified as wrong. That's called complex bashing. And here's the thing, like I don't have my scripts right now, and I have not looked at this problem since then. So I have to, I mean, okay. It's much easier
MNNR
to
centers.
what?
MNNR
MNNR.
centers.
Bruh. Yeah, I have completely forgotten this problem.
Why did you erase the?
Shush. Don't question me. Don't question my bad decisions. I already made one and I like guys, like come on, it's simple, right? You do IMO P1 really fast, then you see like P3 looks impossible. So like you can just spend all your time bashing P2. It's not like you should have like spent that time on P3.
You should have.
It's not like P3, that would be like the one P3 that's like very easy.
You have to switch MN here because the radius is given is less.
Oh, bro, what? Bruh. Fine. This is N. Does not matter. Like config issues don't matter when you are bashing, like until they do right here. Like, but config issues don't matter while you're bashing. I'm pretty sure my solution to this had a config issue. It didn't get detected, but it did exist. Synthetic is some random angle chase though. Of this problem? Of this problem. There are like lots of synthetic solutions. Like I'm pretty sure like everyone has no, but I'm sure random angle chase work. I think like 10 other things also work. Like I think we had 5 different solutions. Like okay, ignore my complex bash. We had 4 different solutions in the team, and then like in like the WhatsApp group, Persian was like, oh, so everyone did this right, and no one had done it. So there was another solution. And also this is like very easy by trig. Complex is like the worst way to do this problem. No, I mean like guys, complex is a very good technique which you should all learn. Thing. So Arnav's controlling this account. I figured it out. Okay, anyway. MN intersects delta CD, MN CD, PB circumcenter of ACD. Okay. So yeah, passing through things. Very good. Very good circle. So like P is somewhere here. AP meets delta at E and tau at F. Okay, guys. Which one's tau? Sorry. I don't know Greek letters. Omega had center M and it meets omega at E. So this one is E and this one is F. H is the orthocenter of PMN. Yeah, so prove that the line through H parallel to AP is tangent to the circumcircle of BEF. So H is the orthocenter of PMN. H parallel to AP. Okay. How do you do this problem? What thing should we take as our unit circle? There are 3 circles in this problem. We finally have to think about this.
Circle through P.
What?
Circle through P, which not through P, centered at P.
Circle centered at P. Okay. And what will you do then? Like, okay, if you have a choice of circle, also tell me how you will compute the stuff. So circle centered through P, C and D are nice, and A is nice, I guess. P is 0. How do you get to like B, E, F, H and M, N? Also, instead of also thinking of unit circle, also like I need some synthetic observations. You can't just complex bash this. Oh, wait, why is H there, bro? It should be like here or something. Yeah. Not even here, like here. Yeah, this is H. Okay. We need a few synthetic observations and then we'll figure out what to. Okay. Yeah, I don't know if circle through ACD work. It might work, but like, how will you compute stuff, right? So, what I thought in contest was that you want a random orthocenter, right? I never want to like compute random orthocenters. Like the only time I'm fine with computing orthocenters is if it's of the unit circle, or if I know circumcenter, because then I can like use centroid to compute it, right? So there are 3 circles in the problem, and I took the one circle that didn't exist and make that my unit circle, PMN, and H as the orthocenter. So PMN and H are nice. Okay?
Yeah, okay.
Yeah. Now, how do you compute, well, everything else? Okay. I need, for this, you will need some synthetic observations. Okay, so first of all, tell me how you will compute C and D. Try to think of that. Also, like the way you do it in like, okay, so I was just like, I need orthocenter, so this has to be my unit circle, and it worked. What you should do is like you should find like nice properties synthetically and see that which circle will that make nice.
Wait, what are E and F again?
What?
What were
E
E and
and
F
F
again? I
are
forgot.
AP cap the circles.
I see, I see.
Yeah, okay, so how will you compute C and D? Hmm. Oh wait, that won't be like trivial, will it? Never mind. No, sorry. I forgot. We don't have A yet. You should compute A first. Hmm. So okay, I retract my question. How will you compute anything at all? I somehow thought we already had A, so then you compute C and D, but nah, we don't have A. So how do you compute A? Let me also try to remember how you computed A because I forgot.
And so when you
Okay, so
yeah, your unit circle is PMN,
PMN,
then
PMN.
then for the 2 other circles centered at M and N, have you taken How have you
Bro,
defined?
I'm not getting. I'm not like drawing any other circles. I'll just do everything with one circle. Right. Okay. So PA equal PD equal PC because P is the circumcenter, right? Right. Yeah. Yeah, that's indeed the case. Okay. I think I remember what was supposed to happen here. Okay, let's draw a better
Yeah, and the
diagram.
angles are also equal.
What
Like
angles are? Yep. Yep.
PD is
Yep.
the reflection of PA and PN. So
Yeah. That's the point. But let's. So you can. Okay. Let's see this triangle again. So you have P, M, N, and somewhere here is like H, and somewhere here is like A, and hmm, yeah, like on the line MN, we have uh oh, okay, I switched them around again. So this is C and this is D,
So can't
and the
A has an arbitrary point.
no A. Okay, let's think about this. How many degrees of freedom do we have in the original problem? Hmm?
Two.
What?
Is it two? I guess. I'm not sure. Like you can choose the two circles and then everything.
Yeah, no, but you choose. No, up to congruence. Like you have to choose two circles, but like a circle is more than 1 degree of freedom, right? It's center and radius.
Okay, so six or something.
No, but like up to congruence. So like you choose the distance between the centers and the radius. So like it's the problem up to congruence is specified by three distances. Distance mn, distance nd, and distance mc. Okay, so Alex, like degree of freedom is like the idea that like how much do you need to like fully specify a problem, right? Like for like how in this diagram, how many distances do you need to be able to draw the whole diagram? No, that's not true. Okay, the problem starts with two random circles, right? So like depending on what circles you take, you can get like a lot of different problems, like a lot of different diagrams. So like it's roughly how many diagrams you can get. So the idea is like you're choosing the distance between mn and you're choosing the two radius, right? So like the triangle AMN uniquely specifies the whole problem. This whole problem is like specified by a single triangle. So, and now we are instead shifting that to PMN. So it doesn't make sense that like A can be an arbitrary point because we have already like fixed 3 points. Like fixing AMN fixes the problem, so fixing PMN should also fix the problem. If that makes sense.
Makes sense. But then
Yeah, it's so like A won't be a random point. You do have to find it. Okay, wait. Uh, yeah, Shreya said something about like these angles being equal. Why is that?
because P is the circumcenter and so PM is
Uh,
the perpendicular
oh yeah,
bisector of
yeah,
AC.
because MC equal MA. M is also the center, right? So PM is the perpendicular bisector. Yeah, PM is the perpendicular bisector. So this angle equal this angle. Correct. So in fact, if you find either A or C, you find the other one because you can reflect about PM, and PM is a nice thing. Similarly, like A, B, C, D, A, C, D, anything you find, you can find the remaining because of reflections, right? Also, can you also notice something? So this angle is this angle, and this angle is this angle, right? Same reason. So the angle CPD is the double of the angle MPN, right? So this whole angle is 2P. And also, PCD is an isosceles triangle, right? And this is like the altitude of an isosceles triangle. So this angle, I'll dash it or something, is equal to this angle. Okay, so let's call this alpha. Let's call this beta. This is also beta. This is also alpha. And okay, so alpha plus beta is our angle P, right? And what's the small angle? This is yeah. I don't know. And okay, and what do we have here? The small angle, let's call that theta. So we have 2 alpha minus theta is like the same as 2 beta plus theta. And like they're both same as half of the CPD angle. And like CPD angle is 2p. So this should be p. Right. 2 alpha minus theta is p. And 2 beta plus theta is p. Right. Um, and yeah, theta will be. Wait, what will be theta be? Theta equal alpha minus beta. Right?
Why is theta?
Okay. What?
Why is theta and alpha minus beta?
These two equations, like subtract them. So you get 2 alpha minus 2 beta minus 2 theta equals 0. Divide by 2. Alpha minus beta equal theta. Right?
What are we trying to compute?
We're just finding synthetic observations. We are trying to see how you'll relate the points.
I see.
So like, so currently what we have is if we have any of ACD, we will have all of them because they are reflections across MN and PN. But like, we don't know how to find any of them so far, right?
You can reflect PC over, you can reflect MN over PM and MN over PN and intersect them to get A.
MN over?
MN over PM
Hmm.
and MN over PN to get A. Because reflection of A over PM lies on MN and reflection of A over MN lies on.
Okay, that's smart. Okay, that's. Wait. So wait, you reflect Mn over Pm, and then you will get N will be. Why will that lie on it? And then
Like first
reflect.
line, yeah.
Yeah, but okay, you don't want to intersect random lines, right? Like the
Are they random
reflection,
really?
but the reflection, like I'll do all this problem without using anything but intersection of unit circle stuff, except at the end. Like reflection of
Interesting.
N will be like here, and like then NM is like very bad. I'll compare. Look, okay, every single point in this problem is nice. The only thing that isn't nice is the final statement. This, yeah, okay, so that will work, but okay, yes, we need nicer state stuff here. So what I'm doing here is just like some angle change, and like you'll notice something. So theta is alpha minus beta. So wait, so this what's this angle? This angle is theta plus beta. So that's alpha. And then this is beta, similarly. So like if like let's draw this diagram again. But oh boy. Wow, my Miro skills suck. So you have PMN. So you had A here. And which one was alpha? Which one was beta? Mm, yeah, alpha was with M. Yeah. So this is alpha. This is beta. And we have shown that if this is like H, then this is beta and this is alpha. That's the angle chase we just did here, right? So we have shown that PH and PA are isogonal lines. So in fact, PA passes through the circumcenter. Yeah, PA passes through circumcenter. And this also gives you alpha and beta, right? Because alpha is like the angle, like it will be 90 minus n. So alpha is 90 minus n, beta is 90 minus m, and yeah, right. Now this will allow us to compute C finally. How? Okay, let's think about this. Okay, another diagram. We have a circle. We have triangle PMN. Mm. So we have the line through P, which makes an angle alpha with PM. And alpha we have just shown is 90 minus n. So, so this angle is 90 minus n. And this is C. Right? This is what we want. This is... everything's correct. Yeah, everything looks correct. Yeah. Uh, okay, so C is an intersect, like, C lies on Mn. Mn is a chord of the unit circle. If we can find this point, we will be done. Because intersection of two chords of unit circle is nice. Right? So how will we find this point? Let me call this C prime. And the thing we have to help us is that we know this angle is 90 minus n. As he says, I'm also trying to remember how we did this, but yeah, any ideas? Let's just write down all the angles. So this will be how did this work again? It's a good question. Hmm. So isn't it 90 plus n never? Yep, you are correct. You are correct. 90 plus n minus p. Try, trying to remember how you finished. I'm struggling. I think like the idea is you prove like some angle becomes like really nice, but I don't remember what angle, which is suboptimal. Let's see. So this whole angle is 90 plus n, right? So this angle is 90 minus n. Yeah, this angle is 90 minus n. And yeah. And this angle is 90 plus n minus p, right? So like these two add up to 180 minus p. So this angle is p. Oh wait, bruh, that doesn't tell us anything. Wait, wait, guys. Uh, I'm forgetting something. Look, some angle's supposed to become nice, guys. Wait, did I do everything right? So we want the line through P. That's correct. Look, the second intersection of something is nice. Trust me, guys.
But it
I have not.
doesn't take. We
What?
don't have to find it synthetically, right? Can't we just do it with the angles?
Actually, that is true. You can just do. No, but I remember like so. What happened was like you end up proving two chords are equal, and like equal chords. Then you like P by C equal M by N, and then you finish. Like that's how you find C prime. But I don't remember which chords were equal. Huh. Oh, bro, we have not.
Okay, no, so like you can take minus m and then we want angle minus m n p to be equal to like
Yeah.
the angle c prime n p c prime n m. So you can
Yeah,
multiply
yeah, I
and
know. And
those
then
two.
you can multiply and then set it to be imaginary. But no, the calculation was really
No, wait,
easy. I
you
just
don't have to set it to be imaginary.
what?
No, so
No.
introduce m prime.
And what's M prime?
It's the antipode of m.
Antipode of M. Oh wait, I think you did introduce the antipode. I'm making sense. Yeah.
Yes, sir. Now you need to rotate m by. Okay, it should be like m prime p by m or something like that. Probably.
M prime P by N, and then you'll get what? Like. Oh you want the like okay. You want to get to C prime, right? So you want this card.
Yes, c prime can be minus m square by p.
Minus M square by P.
Yes.
Yeah, that looks correct. What cards were equal? I've completely forgotten. I need to look at my script again.
No,
Yeah,
so
but
like
okay, yeah,
m
this
prime c prime is
yeah.
equal to mp.
These were this was the cause equal. I don't know why I forgot. Yeah. Okay. Yeah, you're right. This is what I did, but I have forgotten. Okay. Yeah. So what we did was like so okay. So this was 90 plus n minus p, and yeah, and this since these are like antipodes, this is 90. Uh, wait, how do you? Why can't I angle chase? Uh, why is this minus m by p again? Wait, you prove this chord is equal to this chord.
No, so angle m prime n p is equal to 90 minus n. And you want to
M
rotate that
prime.
whole chord so that p goes to m and m will go to c prime.
Why is this angle 90 minus n?
No, that is not 90 minus n.
Wait, which one is 90? Sorry.
M
Wait, which
prime
chord?
n p.
M prime. M prime np is 90 minus n.
Yes, and you want to rotate that whole chord so that p goes to m.
P goes to m, and that you're saying that will send m prime to c prime.
Yeah, because the angle is 90 minus n.
Uh, oh, this angle is 90. Okay, and then hence these chords are equal.
Yes.
Okay, yeah, that works. All I'm hearing right now is this chord. Yeah, but we have finally figured out what to do. Okay. So slight skill issue there because I forgot what I actually did. But yeah, Shreya knows what I did better than me. So we are so back, guys. Anyway, actually, the class is like already 1 hour over time, so maybe I'll. Okay, so I'll just tell you what we did basically. So we have PMN, then we like put minus m here, minus m. So and then what you can do is PM. This subtends an angle of n, and like you can show that this chord C m prime, this will also subtend an angle of yeah, because like this whole angle was 90 plus n minus p, and this angle will end up being 90 minus p. So this angle will end up being n, and like this angle is 90 minus p, like clear, right? Because this angle equal 90 minus this angle, which is 90, yeah, which is this angle. So the point is this chord subtends n and this chord subtends n. If two chords subtend the same angle, then like this is an isosceles trapezoid, PC m prime n. So you get PC equal m prime. So you get PC prime equal minus m square. And hence C prime equal minus m square by P. Right. I know like there was like a bunch of like nonsense there, but does everyone understand what I did?
Yeah.
Okay.
Somewhat, yeah.
Somewhat, yeah. Anyway, yeah. So okay, so actually till this point, like when I was in contest, till this point I wasn't actually thinking of complex bash. So I had done this angle chase. I had found OP is the diameter. Then I noticed oh, nice things like, then I noticed these chords are equal. Then I realized, oh wait, that means I can compute C. And at this point, it was over. I have given up on synthetic already. As soon as I realize I can compute C. Yeah. So you have four very nice points in the intercircle, in the unit circle. So you can intersect to get C. Symmetrically, you get D. Reflect either and you get A. So you have C, D, and A. Where's stuff? Wait. No. Yeah, here. So left is B, E, F. How do you get B? Hmm? B is easy to get, relatively.
Reflect again.
Yeah, reflect A in Mn, that's B. Like, because these are two circles, their intersections are, so you can get B very easily. How do you get E and F? That's harder.
Like drop a perpendicular from, okay, I don't know, M to PA and reflect.
Yeah, exactly. You're correct. Yeah. Uh, so instead of M, we just proved PA is the diameter, right? Like PA passes through the circumcenter. So you know there will be like a minus P here. So uh, dropping a perpendicular from a random point, and it's not even a random point, it's M, to a chord of the unit circle is nice. So you'll get like, let's once again look here. So you have M here, you have A here, you have E here, A, E, and you know P lies here, and you know P prime lies here. Uh, Probably P prime lies somewhere here. Right. P prime is minus P. So you can, dropping a perpendicular from a point to a chord of the unit circle, that's easy. And since this is the center of the circle, that will give you the midpoint of A and E. You reflect A over this and you will get E. Symmetrically, you get F. Right? Is that fine with everyone?
Yeah, no, I
And
don't
this
get
is
it.
why we did the angle theta at the start. This is because we need the P prime. We need to be able to drop a perpendicular from M. This line is nice.
What did
So
you say?
now you have all the points in the problem.
Can you repeat what you said just now?
Um, so you want to find the E. So you know E is the reflection of A over the midpoint of AE. And since like AE lie on the circle with with center M, their midpoint is the foot of M onto AE. And AE is same as AP. And we prove that like AP is like, it's isogonal to A, like PH. So it has to pass through the circumcenter and hence like minus P.
Yeah, I got it. Yeah.
Yeah. So you drop a perpendicular from M to P minus P, chord of the unit circle, everything is good. And then you reflect A over this. You get E, you get F. So you have gotten B, E, F. And I know there was like skill issue there, but all of these points, they're not that bad. Right? And now H is good, B is good, E is good, F is good. And the direction AP is also good because it's just the direction of P. It's just the direction OP. Because once again, AP passes through the circumcenter. Everything is good. So to get the tangency, uh, so H is M plus N plus P. So like I'll just write this M plus N. So the line through H parallel to AP is M plus N plus like P times a real number. So like it's M plus N plus P plus P times a real number. So, but like I just like T plus 1 I reset as T. So it's just M plus N plus PT. So you set M plus N plus PT, B, E, and F. You set these 4 points as cyclic. You get a quadratic equation. You prove its discriminant is 0. And well, actually, what you end up doing, you just prove it's a perfect square. And you are done.
Wow.
This last part is not easy. This is very ugly. Some tips. So, you know that A lies on the line OP, right? So like A, whatever expression A ends up being, A by P is a real number, right? So what you do is you write A as like P times S, and then you do all our computation in terms of S. And this is like good to do because you have to take conjugates a lot of times. And since you know S is a real number, well, the conjugate is very easy. It's just S itself, right? So E, B, F, you write everything in terms of S. And only at the very end that you put the value of S. And when you set the cyclicity condition, you will actually end up with, if I remember correctly, T plus S square. So S shows up again. So the cyclicity condition reduces to times some constant equals 0. Single. And then how much time did I take? 2.5 hours, maybe more. I don't remember. Like P1, I was like done quickly, but like I took some time to write up. Yeah, oh yeah, it was I think 2.5 hours. Like P1, I took like an hour for like everything plus write up, then 2.5 hours for this. Then I had like 1 hour left for P3. But then no, I tried P3 for like a bit, but like I think in like first 20 minutes I had nothing, and then I decided that P3 is probably impossible, and I should go back and check my bash and ensure I don't get 0. And I should also check P1. Yeah. P3. The probably impossible problem. Anyway, so this problem, so like the main like key takeaways, first of all, like choosing a unit circle. You want to choose a unit circle that will like make the final things easiest to do. H. So like that's why I choose PMN because you wanted orthocenter. I have not posted this bash yet. I will post it one day. I promise you. Anand apparently told me that like apparently there were only 5 complex bashes total for P5. Sorry, P2, which is less than the number of solves there were for P6. So complex bashing P2 is a bigger achievement than solving P6, guys. This is the hopium. This is the copium we live on.
How many pages was your bash total?
I think 8 or 9.
Okay, that's fine.
It's not bad. Like the first 2 pages were like just these synthetic angle chases to prove this is a diameter and stuff. I'll have to check. It might have been 10 or something. There's a few pages of roughbook attached, so I think it went bigger, but that one did not crash. It's not that big a bash, guys. Like honestly,
Wait, how
like
did the tendency again? Can you just explain?
oh, tangency is you brute force it. So you want the line through edge parallel to AP, right? So what's a general point on that line? It's it's like h plus p times a real number, right? Like okay, you want the direction of AP, but AP passes through circumcenter. So the direction of AP is the same as the direction of OP. So that's just like p minus 0, right?
Yeah, yeah.
So h plus pt, and like h is m plus n plus p, so I like set t plus 1 to be the new t. So m plus n plus pt. This is a random point on this line,
Okay.
right?
Okay.
I set it cyclic with BEF, and I get the quadratic equation. And I say the quadratic equation has a single root because it's reduced to this t plus s square times c equals
Okay,
0.
explain it. Yeah, it makes sense.
Yep. And you're done. When's this gonna be? Ask the dictators. Anyway, that's the last problem we are doing. I'll just like quickly recap. Like the main takeaway from this problem is reflections in unit circles are incredible. Everything is computed using a reflection. Reflection of D, A. Reflection of A, C. Okay, but C, okay. And reflection of A, B. Reflection of A across foot of B, H. Sorry, E. And then you get F. Everything is a reflection. Even to compute C and D, we reflected in the circumcenter to get the antipode. Like this problem is just how do you reduce everything to a unit circle computation? Like like the biggest hurdle to bashing is realizing that C prime is nice. After you figure that out, everything else is like obvious until like this final nonsense that you have to like work through. But come on. It's like you can do some nonsense. Okay. So I hope like people have like learned I didn't do any calculation. I just tried to like give you the main idea. I'll stop sharing. The basic recap of this class, considering circumcircle PMN is H. Like, if I consider any other circle, finding H would be a nightmare. The only way I can ever find H is like PMN. That's the motivation. There might be actually other bashes possible, but I don't know. I just felt like I have no other. I couldn't see any other way of finding H other than it just being like the unit circle orthocenter. Yeah. So the basic recaps are, first of all, you draw a good diagram so you can guess claims. Second is like synthetic plus bash. And the final thing is like good choice of unit circle. You like never use lengths alone, like unless they are squared, etc. I like can't not much more to say than that. Also, every computation I skipped in this class, homework is to do them.
Okay.
So that's TSTP2. I mean, EGMO is like one line. Yeah, so TSTP2, TSTP3, and IMOP2. Just carry out the calculations. And yeah, IMOP2 post the batch on AOPS. So like I can like control C, control V when I'm posting mine. Anyway, any questions, comments?
How do
We are
you
1 hour over
accomplish
time. What?
the Serbia problem?
The Serbia, once again, that's one problem I have not done. Look, if you want to, like, I'm ending the class right, but we can stay and figure out how we bash it.
Yeah, I will stop recording, I guess.
Yeah, you can stop
Unless
recording.
any questions.
Yeah, I mean, any question? Yeah.
Okay, I'll stop recording.